So we're now ready in this section to talk about probability. In the last presentation, we learned about setting up a tree diagram to list out the possible outcomes in the sample space. So we're now going to use that sample space to answer some questions about probability. Remember that probability is the chance of something happening. The formula that we're going to use to calculate probability is the number of favorable outcomes divided by the number of possible outcomes. And when we talk about the number of favorable outcomes, what we're really referring to are the outcomes that match the criteria that we're asked about. So these are the outcomes that we want. And then the number of possible outcomes will be the total number of outcomes in the sample space. So we're going to start with a couple of really easy basic examples just so we can get an idea of how the formula works. So our first example says that Terry flipped a coin in the air 20 times and 9 of the results were heads. What is the probability that a randomly selected coin flip from her set of 20 resulted in heads? So she flipped the coin 20 times and she got heads 9 times. And now we want to know what is the probability that she got heads. So the number of favorable outcomes is going to be the number of outcomes that meet the criteria that we're being asked about. So we want to know how many probabilities, what is the probability that a coin toss resulted in heads? So we know that she got 9 heads when she flipped the coin. So there are 9 favorable outcomes. There are 9 times that we got what the problem is asking us about. And then the number of possible outcomes, that would be 20. That would be the number of times that she did that experiment. So our probability of getting heads would be 9 out of 20. Okay, another just kind of basic example just to see the formula. There are 30 people in my class and 13 are seniors. Find the probability that a randomly selected member of the class is a senior. So if I'm looking for the probability of a senior, the number of favorable outcomes will be 13 because there are 13 seniors, and that's what we're looking at. And then the number of possible outcomes, that will be the total number of people in the class. So 13 out of 30 would be the probability that we choose a senior. Okay, so with those 2 examples underway, what we're really going to look at today are some examples that are basing the probability on the sample space that we came up with in the last section. So we're going to do 6 examples here and just kind of walk through each one. These first 3 talk about rolling a single die. So remember that your sample space for one die contains the numbers 1 through 6. So I'm going to go ahead and list that out so that we can see it. All right, so you roll a single die, find the probability of rolling a 4. So I know that the bottom number on my fraction is going to be 6. Because there are 6 things in the sample space. 1, 2, 3, 4, 5, 6. So the number of possible outcomes will be 6. Now on the top, I need to know how many of the outcomes meet the criteria that we're asked about. So how many of these outcomes are 4s? And there's just one of them. And so our probability of rolling a 4 is going to be 1 out of 6. For our second one, we want the probability of rolling an even number. So again, we're going to have 6 on the bottom because that's the number in the sample space. Now we want to know for the top how many meet the criteria of being even. Well, we know that we have the 2, the 4, and the 6. So how many are even? That would be 3. And 3 out of 6 is going to reduce to 1/2. And our next one says we roll that single die. We want to find the probability of rolling a number greater than 4. So again, 6 on the bottom, because that's how many outcomes are in the sample space. Now for the top, we need to know how many meet the condition of being greater than 4. So greater than 4 would be 5 and 6. So that means that there are 2 options that meet my condition. And so the probability will be 2 out of 6, which is going to reduce to 1/3. Remember that your calculator, if you were able to purchase the calculator for the course, your calculator should be reducing these fractions for you. So if you have your button that has the F and the arrow and the D, that's going to change in between fraction and decimal, and it's going to reduce that fraction for you. Okay. All right, so now we're going to move to a set of 3 problems where we're rolling 2 dice, and we want to know the probability of various things. Now, I want to remind you, I'm going to go back to what we did in the last presentation real quick. I want to remind you about the 2 dice. Remember that the sample space has 36 possible things in it. Okay, so we're going to keep that in mind, that 36 possible outcomes is going to mean that when I calculate a probability for 2 dice, for example, on the first one we want the sum to equal 4. Because there are 36 possible outcomes in the sample space, I know that all of these are going to be out of 36. Okay, now to come up with how many outcomes meet our condition and are favorable, we need to probably make a list. So you need to think about the different ways that you can roll a 4 on a set of dice. So I'm just going to kind of make a list here. I could roll a 1 and a 3, and that would give me a sum of 4. And remember that you always want to turn the numbers around, so you could roll a 3 and a 1 as well. And that counts as 2 separate outcomes. Is there another way to roll a 4? Well, we could roll a 2 and a 2. And remember that those don't get turned around. So of those 36 outcomes, there are 3 ways to get a sum of 4. And 3 divided by 36 is going to reduce to 1/12. All right, let's look at our next one. Find the probability that both die land on the same number. So we need both to land on the same number. Now again, the sample space doesn't change. So if we're rolling 2 dice, our problem is going to be set up out of 36 possible outcomes. All right, so how many ways can both die land on the same number? Well, that would mean that we had rolled like a 1 and a 1. Or we rolled a 2 and a 2. Or a 3 and a 3. 4 and a 4. 5 and a 5. 6 and a 6. So those are the only ways that we can roll things where both of the numbers are the same. So how many ways can that happen? There are 6 ways that that can happen. So our probability is 6/36, which is going to reduce to 1/6. All right, and for our last one, we want the probability that the sum is greater than 5 and less than 8. Okay, so let's think just a minute what that means. Greater than 5 is going to be a sum of 6 or 7. And we need to stop there because we also want that sum to be less than 8. All right, does that make sense? So if you think about your number line, we want greater than 5 and less than 8. So the only things between those two are going to be 6 and 7. All right, so again, I know that my probability is going to be out of 36, and now I just need to figure out how many different ways I can do a sum of 6 or a sum of 7. So let's start making our list. So for a 6, I can roll a 1 and a 5, and a 5 and a 1. I can roll a 2 and a 4, and a 4 and a 2, or I can roll a 3 and a 3. So that's all the ways to make a 6. All right, what about a 7? I can do a 1 and a 6, a 6 and a 1, a 2 and a 5 and a 2, 3 and 4, 4 and 3. All right, so count the number of outcomes that meet the condition. So we have 5 and 6, we have 11 outcomes, and 11 over 36 does not reduce. So the probability of rolling a sum of 6 or 7 is going to be 11 out of 36.